Good morning, everyone. I wish a good morning to all the participants, all the audience of User Group Mumbai. Thank you so much for joining us in this wonderful morning. I know Saturdays are a bit lazy and specifically in the morning times, but I really appreciate that you took out the time from your schedule to join us. I would make sure, like I've done last time, that we have a very wonderful session and we all know who's the speaker for today. So there is no surprises. But let me make some announcement before we go ahead and go live. So please ensure that if you have any questions, any queries in the chat, please put it in the chat section. I'll show you in the chat once the session starts. So keep putting your questions on the chat. Abhishek will ensure that he will answer the questions at the every logical pause around it. And with that, let me talk about the session. So today, for the first time in our user group, we will be learning about Manage Kafka, which is a very renowned service in AWS, and it's really picking up in the market everywhere in all sorts of solutions. You will see a common term which is called as Kafka. So let's understand how exactly you can simplify leveraging the Kafka in an AWS way. And from to cover that topic, I can have the best person with us, Abhishek Gupta, who's a principal developer advocate at AWS and very well enthusiastic when it comes to different data services, big data, whether you talk about Kafka, whether you talk about Redis, Redshift, Glue, he's very renowned. And he'll be with us today to talk about his experiences, how he has seen Kafka growing, AWS managed Kafka, and what are the common other scenarios. So with that, let me introduce Abhishek on the screen. Hey Abhishek, good morning. How are you doing
Hey,
today?
good morning, folks. I'm good. I'm good. Thank you. How are you doing, Sanchit?
I'm doing good. Thank you
Awesome.
for spending out time from your weekend to help us to understand what is exactly the Kafka and how exactly AWS managed Kafka can help us here.
No, I'm happy to do that. Thanks. Thanks so much, Sanchit, for having me. First of all, this is my you folks know, right? This is my first session. You haven't seen me before, so first session with Mumbai User Group. I'm super excited and glad that Sanchit reached out and we had the chance to speak to you all. Appreciate that. I'm Abhishek Gupta, based here in New Delhi, India, and the winter is here. It's getting colder day by day. Of course, not the same in Mumbai, I guess, but yeah. So one of the first things I'm going to do, like for the rest of the weekend, is to try and unpack and prep all my warm clothes and so on and so forth, because I just have a couple of jackets out there. But yeah, so that's my weekend homework. But before that, I'll do something useful, talk to you folks, and chat about MSK and Kafka and things which I love. So just to give you a very very quick background about myself. So currently I'm a developer advocate at AWS, as Sanchit said, but in the past I've been very very lucky to have worked in a variety of roles at other cloud providers as well, in PM, product management, engineering, and even consulting, and so on and so forth. So I've seen a bit of everything, but yeah, for now databases, containers, and open source in general happen to be some of my focus areas in my current role here. uh, Again, Sanchit already sort of iterated this, but I'm going to repeat that. But I'm going to talk about something called Amazon MSK, or it's also called Managed Streaming for Apache Kafka. I realize it tends to get a bit of mouthful, saying, managed streaming for Apache Kafka all the time. So I'm going to use this, sort of short term over and over again. I'm going to call this MSK. So you'll hear that word from me now and then. So just know that it's managed streaming for Kafka. And before I move on, I'm going to add a disclaimer here, right? And look, it's the weekend, and folks tend to get very enthusiastic. I don't know, everywhere in India, right, including Delhi. So if you hear maybe some music or some or anything odd, please excuse me in advance, because it's one more thing. It's winter and it's super super duper quiet, and even that tiny bit of noise tends to get amplified. So thanks for understanding. So just a call out in advance, right there. Yeah. Cool. And I'm happy to take questions. I'll just pause in between and check with Sanchit in terms of, if you have any queries, doubts, happy to make this as interactive as we possibly can. Okay. So we have about 60 to 90 minutes, right, Sanchit? Like that's what we had discussed. And so let's see how this goes. But I'm planning to keep this at 200 level, right? I'm like, introductory and then 200. And hopefully at the end, what I am, planning to do is, or my expectation is that you'll have a reasonable overview of MSK and some of its components and ecosystem and so on and so forth. And yeah, I'll start off with an intro to Kafka in general, just to set the context for you folks. And then dive into MSK, MSK Connect, and even some of the serverless, options in the MSK world. And there'll be demos along the way, obviously. So yeah, without further ado, we can get right to it. Kicking off with Kafka 101. All right. So when I asked myself this question many years ago, like what is Kafka, and I, sort of, excuse me, I got into Kafka. Uh, I don't know when was it, 2014, 15, something like that, right? Of course, I was searching for material, and I stumbled across this awesome blog, and this was sort of this eye opener to me. And later, I think this was it has also been formalized into a very very short book, so I highly recommend that you check it out. But although I cannot spend a lot of time on this, but what I want you to understand in terms of this question about what is Kafka is that at its core, it's a distributed append only log data structure. I know a lot of buzzwords. It's okay if you don't understand that, but I think it'll be useful for you to sort of remember this when you go and research in terms of, hey, I want to understand more about Kafka, what it is, so on and so forth. So remember these three words: distributed, append only, and log data structure. And yeah, whenever you have time, I recommend going through pretty much everything what this gentleman known as Jay Krebs wrote. He's one of the original co-creators of Kafka, the open source project. And the second thing is that you will hear many terms for Kafka. And to be very, very honest with you, it will be confusing. You will be overloaded when you first try to grasp what it is. You'll read articles where it will be referred to as, a message queue. Somewhere else, it will be called a topic. You'll hear the word pub subsystem. So a lot of terminologies will pop up to try and explain Kafka. But really, the second point is it is a distributed streaming platform. Remember these words again, right? And hopefully one of this is from 2019, one of these blogs which I wrote, and there are tons of other good blogs as well, but of course I'll do some self promotion as well. So I wrote it. It has been helpful for many people. So if you get the time, maybe you can check this out in terms of what exactly is Kafka, right? So in the next few slides, I'll try and break down some of the Kafka related terminologies. We are not into the MSK land as of yet. I'm talking about Kafka in general. So some of the terminologies, some of the concepts, so that you get some sort of a baseline or a foundation. And I'm assuming that you folks are new to Kafka. If not, this should be a good refresher for you, hopefully. Okay, so in Kafka, what happens is all of this data, right? At the end of the day, Kafka is a messaging system. It's a distributed streaming platform, right? And data within Kafka is stored in logical buckets called topics. Okay, so you can think of a topic as very, very similar to a folder in a file system, perhaps. And all the data that I'm talking about, think of them as files in that folder. Okay, so a topic could have data related to orders or payments or users, depending upon your use case. There is no restriction as such. And then in addition to topics, there are these client applications. So on one side you have producers, and on the other side there are consumers. I mean, it's very, very self-explanatory that producers are sort of these client applications that publish or write data, or they're also called events, right? So they write events or data to these Kafka topics, and consumers on the other side, they subscribe to that data and read and process these events. Okay, now these producers and consumers are nothing but they're encapsulated in the form of client libraries for different programming languages. So it could be Java or Node or Golang or Python or .NET, you name it, right? Pretty much all the modern programming, all the modern or not modern is not a discussion, but pretty much all the standard programming languages are covered by Kafka, right? So essentially producers and consumers are part of the standard client library. And another important point for you to realize and know is that these producers and consumers are completely decoupled from each other. They don't know that the other sort of person exists, right? So producer doesn't know how many consumers are there, and consumers don't know how many producers are there. So they're completely agnostic of each other. So this is a very, very key design element of Kafka, and you'll understand that a little bit later on as well when I dive into some of the other aspects. And each topic, so we have topic, we have producers, we have consumers, and each of this topic is further divided into things called partitions. Okay, so think of think of these as perhaps drawers in your cupboard, right? Something like that. So a data in a topic, what happens is it is spread across multiple machines where you have different Kafka brokers. Now, this distributed placement of these events and these data is very, very important for scalability and high availability. So because what happens is it allows all these client applications, these producers and consumers, to read and write data from and to many brokers at the same time. And partitions actually play a very, very important role in terms of giving Kafka the ability to have this distributed architecture, right? Ultimately, like I said, it's helpful for both scalability, high availability, as well as redundancy and fault tolerance. Okay, so essentially there are multiple copies of your data stored across multiple machines and within your entire Kafka setup or installation. So here's what happens. Okay, so when producers write data, what happens is there's actually a hash function which is run. So essentially Kafka stores data in form of key and value pairs. So key is optional. You need to obviously put some value in there. Yeah, you can put null, but that's a different discussion. I won't go there. So key and value pairs essentially. So the key, whatever key you assign for your data, it is actually run through a hash function, and the result of the hash function decides which partition the data goes into. Okay, and if there is no key, right, the key can be null, the allocation is which the partition is chosen on a sort of random or round robin basis. Okay, now there's a lot of detail associated with it in terms of the partition algorithms and so on and so forth. To be honest, I mean, we cannot go over all of that right now, but something which you can definitely sort of research and check out later, right? But for now, just understand this. And as you write data, what happens is that it creates something called an offset in that topic partition. Okay, and like I said earlier, it's an append only log design. It's like, think of Apache web server logs, for instance, right? What happens is you don't really override data. It keeps on getting added to these topic partitions, and every time you add data or write data to a topic partition, a new offset is created. Offset is like think of it as a pointer, right? Which you can use later to consumers actually use that later to sort of get the data and so on and so forth, and do some housekeeping operations, right? So on one side you have producers which write data to specific partitions, and like I said, you have consumers which receive and process data. And typically what happens is these consumers, multiple consumers, can be in a consumer group, and they collaborate together to load balance the data processing workload. So you can have many consumers in a group. Well, I should put it this way: the maximum number of consumers within a consumer group can be only as large as the number of partitions you have for a topic. So, for instance, in this example, you have a topic with, say, multiple partitions here, right? In this case, 3 partitions. Okay, so what happens is you can have a maximum of 3 consumers. You can have 1, you can have 2, but a maximum of 3 consumers, and each can process data from each partition. If you have more than 3 consumers, that's fine, but then it's not going to be actively participating in the data processing. The entire, it will be sort of a inactive consumer. Okay, so what happens is this: now if a consumer goes down, okay, there will be something called a rebalance which will be triggered by Kafka. And what will happen is the partition data will be reallocated amongst the remaining consumers. Okay, and then the processing is going to continue as is, right? So remember, I spoke about high availability and reliability, even in terms of producing as well as consuming, right? So that is where partitions actually help, because you have multiple partitions and multiple consumers. If one of the consumers was to go down, data processing will get rebalanced or redistributed amongst other consumers. Okay, and what happens is once the crashed consumer or your application, maybe it had a bug, whatever, once it comes back on, this rebalance is going to happen again, and then the load is going to get redistributed back to the remaining number of consumers, right? So this is how the consumers actually cooperate and sort of load balance the data processing workloads. Okay. All right, now when you put all of this together, the concepts around topics and partitions and consumers and rebalancing and so on and so forth, okay, this is what of kind of what it looks like. I mean, you will see different versions of similar architecture diagrams or diagrams in general. So a Kafka cluster, this is just a recap, right? It consists of multiple nodes or broker, of course, each running a separate sort of copy of the Kafka, the software aspect. And then there are multiple topics, like I said, with multiple partitions, and each topic partition is actually replicated across these brokers for scalability and high availability. And every node actually has two distinct roles. It can be a leader and a follower for different set of data. Okay, so in this example, it just happens to be that broker 1 is the leader for partition 0 of topic A. Okay, and what this means is that writes for this particular topic partition, the partition 0 of topic A, will go to broker 1, right? And there are other, broker 2 is a leader for other and a follower for some other topic partition, and so on and so forth. So essentially what happens is, this is how the architecture scales. And the data replication which happens, it happens in the background as an asynchronous process. So you can actually configure that, but by default it is asynchronous in nature. So when you write data to a broker in Kafka, it gets sort of replicated to other cluster nodes as a background process, so that you don't sort of tie in other resources and threads and compute resources just to sort of hold your client there, block your client, and wait for all the replicas to get in sync, right? So that happens asynchronously. Cool. Okay. Now, before I actually move on, and now I'm going to talk about some challenges and other aspects as we move into MSK, I'm going to pause here for a second and just check if you have any questions on some of the core aspects, or Kafka 101 or general intro to Kafka. Of course, I couldn't cover everything, but it's just a very sort of a I just gave you a very small capsule like information. So happy to take questions here for a minute or so. Let me know, Sanchit.
Yeah, Abhishek. So there is one question. The question is: are partitions tied tightly tied to a consumer? If yes, how it is decided which consumer will be tied to which partition? Can't
Yeah.
any consumer consume from any partition? Uh,
Yeah.
Almost heartability.
Yeah, so this is actually done behind the scenes. As a client application, you don't really decide as to which partition you're going to get coupled to from a consumer perspective, right? So imagine this: you have three partitions. I'm going to stick to the same example. Actually, you know what? I'm going to go back here. It's going to be easy, and I'm going to cover this quickly. So you have three partitions, and assume you had only one consumer in the beginning. So that consumer is going to consume from all the three partitions in that topic. You bump it up, right? And again, you right now you have just one consumer, and then you bump it up and you get a second consumer. So what will happen is, one of the consumers will consume from two of the partitions, and the other consumer will just have one partition allocated to it. Which consumer gets allocated to which one, it's actually done on the server side. That's a different logic. It's done by one of the controller nodes in the cluster itself. As a client application, we don't really decide that. And from two partitions, when you go to three, then the equation is actually very, very simple. So we don't need to think, right? Because there are three partitions. So it's a 1-to-1 mapping there, right? So yeah, to answer your question in short, we don't really decide that from a client perspective. It's the server which does all the magic and the rebalancing and all those kinds of the heavy lifting. I hope that helps. If not, just let me know, pop it in, and I'm happy to clarify as well. Cool. I think no news is good news. I hope that was helpful. But yeah, feel free to reach out later on or interrupt me if it's not. Anything else, Sanchit? Any other questions for now?
No, I think that's a question, and we just got a response. I think that
Okay.
clarifies his question.
Oh, awesome. Cool, Sagnik.
There is one more question. I think we just got. Sorry, from
No
Taushik.
worries. Mhm.
Consumer and consumer group read from mutually exclusive pattern.
Yes, that's right. Good point. Yes, absolutely. Because again, like I said, in order to distribute load, so if you have two consumers, say, and three topic partitions, so consumer one will say have listen to partitions 1 and 2, and the second consumer will have allocation to partition 3. So yes, it is mutually exclusive, and that's how the load is balanced. Good point. Thanks for calling that out.
That's it. I think those were the questions.
Awesome. Cool. Let's carry on, and I can always come back to this if you have more questions. All right. So I spoke about Kafka in general. Kafka is a distributed system, but nothing in life is perfect, right? Neither system, neither humans, and same goes for Kafka, right? And it's a distributed systems, but that inherently actually brings some very obvious challenges. It has multiple moving parts from an infrastructure perspective, especially Zookeeper. I'm not discussing that in depth, but there is another sort of component to Kafka. It's called Zookeeper, and it's sort of this. You can think of it as sort of a CPU or a brain of Kafka. In addition, I mean, but in recent versions of Kafka, Zookeeper is actually sort of going away, or already has gone away. I think it was version 3. I forgot 3.10 or something like that. But you can double check that, or maybe even 2.9, something like that. But anyway, for older versions of Kafka before 2.9 or something like that, Zookeeper has always been sort of the center of attraction as well from a maintenance perspective. So it is very, very difficult. Trust me, it is very, very difficult to set up a production and maintain a production grade cluster, maintain reliability, high availability, scaling your cluster up and down. So all in all, it's a lot of overhead in terms of cost and technical resources, and that is something which customers can actually allocate for their core business rather than doing all this heavy lifting, right? So, and I think this is not something new. I'm not talking about something new. It is inherent to a lot of distributed systems, and when you try and run this at scale, right? And obviously, if there is a problem, there is a solution, and this is where I talk about MSK or managed streaming for Apache Kafka. And obviously, being fully managed is definitely one of the big ticket items here. Okay, uh, but I want to clarify this, and I know this word gets thrown around a lot. Fully managed, hey, fully managed. You don't have to do anything. But really, what do I mean by fully managed? And just to clarify, maybe some of you already understand that, but just to set the context, right? From a Kafka and MSK point of view. Now, if you were to try and set up, say, Kafka on premises, you'll have to take care of this entire spectrum of tasks, hardware and software and Kafka and, like I said, Zookeeper, maintenance, patching, I don't know, Log4j, Spectrum, Meltdown, and all those sort of things. Think about the security aspects and making sure at the end of the day that it scales with your data and your workloads, right? Say you use EC2, you can offload some of those aspects, but still, I think about 70% of the heavy lifting is still going to be done by you. But if you compare and contrast that with something like MSK, a managed service, you're pretty much covered on all the bases except for your application or your workload, because MSK or AWS or Amazon in general is not going to know what you are trying to do. So yeah, you'll have to take care of your application tuning and this and that. There are a bunch of things there, but yeah. So in term, this is sort of the spectrum of on-premises EC2 and what you sort of tend to gain with a fully managed sort of service, any fully managed service for that matter, but applies to MSK as well. Okay, all this looks good. So a lot of stuff which MSK promises. So let me walk through that. Now, I know next few slides are going to say features, but to be honest with you, these are more, of fundamental capabilities of MSK. Yes, there are features, but they're like sort of the core foundation. So I'm going to kick off with the security aspect here. So for anyone who has worked with any AWS, or Amazon managed service in general, perhaps a database, right? You'll be aware of these security tenets, right? So there are multiple levels of security actually. I'll start off with encryption at rest. Okay, because MSK integrates very, very tightly with AWS Key Management Service for it encrypts all your data at server side. Okay, and at rest as well. And when you talk about rest, it makes sense to talk about encryption in transit as well, because MSK uses TLS 1.2 by default. So essentially, all the data which goes in between different brokers in MSK, as well as between your client and brokers, right? They can be encrypted. Now, for broker to broker communication, TLS 1.2 is default, but I believe for client to broker communication, you can configure it the way you want. You can have a combination of TLS, and I believe it is there are a bunch of combinations actually. I forget, to be honest with you. So it can be TLS and plain text based encryption and so on and so forth. So it's kind of covered, the encryption at rest and transit, and obviously authentication and authorization. So in case you haven't worked with Kafka, that's fine, but Kafka actually has its native authentication and authorization mechanism based on, again, TLS. You can use something called SASL. Its full form is always a mouthful. I'm not going to try that, but basically username password based authentication, right, is what Kafka uses by native. But with MSK, you can also use IAM, which is sort of tightly integrated. And I'll show that to you in a demo as well. Hopefully, I'll get there sooner rather than later. And yeah, as expected, there is VPC network isolation as well, which I'm going to cover now. So by default, your clients can only access an MSK cluster if there's that VPC configuration setting, right? So you have to be in the same VPC as the cluster, and the standard sort of AWS configuration in terms of having a cluster security group where you have an inbound security rule that accepts traffic for MSK from the client's security group. Okay. Now, just a heads up, I am actually hearing some noise as it sort of passes by my house. It might sort of amplify, so heads up in advance. But I'm going to carry on, and yeah, apologies in advance. I'm not going to mute myself or interrupt this presentation. Hopefully, it should not be too much of a problem. So, yeah, like I said, VPC, very common configuration, right? It's by default you have to be in the same VPC to communicate with the Kafka cluster. And it's you can obviously set up high available clusters as well. I think I have sort of told that in background already. So typical production grade setup will have a cluster with at least 3 nodes, 3 Kafka brokers, and these are spread across multiple availability zones within a region, right? So here, of course, I'm showing you an ideal setup where you have 3 brokers and AZ1, AZ2, AZ3. Again, since it's MSK is actually running Kafka behind the scenes, right? Open source Kafka. You can actually expect pretty much all your applications, right? I mean, of course, it's not a hardbound promise. Nothing is ever 100%, but you can expect almost all of your existing, Kafka applications to be able to work with MSK and to be compatible with the Kafka sort of ecosystem of all these tools, right? And these include, core parts of the Kafka ecosystem like Kafka Connect or Kafka Streams or Mirror Maker. I know I've not mentioned all these things. It's fine. Just try and understand that if you are using, say, a Kafka Streams based application on, say, a on-premise or an EC2 based Kafka cluster, it will most likely work with MSK as well, with some modifications, of course. Or maybe you're using tooling such as schema registries and different CLIs for Kafka and whatnot. You can expect that again with some level of configuration and tweaking things here and there, it will work with MSK. But there are things that you cannot do and tools you cannot use. So first thing first is, remember, this is a managed service, so you cannot mess with and sort of SSH into the system and mess with the file system, upload jars and libraries. You can't do that. So that is definitely something to be mindful of. And that means that you can't use tools like some of these tools which I've mentioned here, right? So I've called them out. I guess there are a bunch of other tools as well. Not that I know everything under the sun, but for sure, tools which need you to upload stuff to the file system directly. Sorry, you can't do that with MSK as of now at least. Yeah. Again, we want to simplify all of that for you. So yeah, I've been rambling. Kafka, MSK, why it's awesome and everything, but I want to stop rambling now and go into some demo and yeah, some basic stuff. Essentially, just change gears a little bit. Yeah, and just to be conscious of time, I'm going to go ahead and pause for questions later. I hope that's okay, Sanchit. I mean, yeah. So just something to be aware of. That's all. Yeah, I'm going to move into the demo so that we don't miss some of these aspects. Okay. All right, cool. I hope you can see my screen, and I'm in this AWS console. So first things first, let's look at this MSK cluster which I have. So I have 2 clusters here. The other one is the serverless. I'm going to talk about that later. This is the MSK provisioned cluster which I have here. So as you can see, the cluster summary, this is obviously active. This is running Kafka version 2.6.2. There are 3 brokers, like I said, very ideal setup. I have that across 3 availability zones. If I were to go into the properties section here, and if you see some of the configuration, I'm going to scroll down and just notice the networking settings here. So I have like three subnets, each for a different AZ, and I have a security group applied here as well. Public access is off. I'm going to talk a little bit about public access later on as well. Network settings, we have the brokers here. Yeah, these are the individual broker endpoints and the subnets with which they are associated with. We have, of course, the storage configuration. And by the way, I have said all of this. It takes a lot of time for us to set up the cluster. So yeah, I'm not going through that process. I mean, it's not a big deal, to be honest with you. But I want to understand. I want to make sure you understand some of the configuration parameters. So I'm just sort of going past this real quick. And the important part is some of the aspects around security settings. I called them out earlier. So in this case, I am role-based authentication active. So that's what I'm going to use for the rest of the demos. I just had unauthenticated access as well for some of my testing. I don't recommend you do that, but just for my, I was just playing around. As well as encryption, like I said earlier, within the cluster, we have TLS encryption sort of by default, and I have The same for clients and brokers as well. I have TLS as well as plain text enabled. Just for demo purposes, to be honest with you, right? You can actually shut down plain text if you wanted to. Yeah, I think that's it in terms of the basic sort of cluster properties, and this is something you would enter yourself if you wanted to sort of create this cluster, of course. And I'm going to scroll up here real quick and show you this client information sort of hidden there, but yeah. So if I once I click there, what you see here is three sort of columns, right? And if you notice, we have the authentication type and a private endpoint. So because I have multiple authentication types configured for this cluster, which happens to be plain text and TLS and IAM, remember that the endpoint, the connectivity endpoint for your cluster that you choose is actually going to differ based on that. So what differs is actually the port here. So if you see, I'm going to use IAM authentication for my demos, I'm going to use port 1998, and these are the individual sort of brokers, right? You can simply copy paste from here and sort of have that in your application or whatever whatever you're configuring to talk to the MSK cluster. Yeah. So this thought I'll call it out because there's a very common sort of mistake which people make, like they want to do TLS, but they because 1992 happens to be Kafka default as well for open source, so they use 1992 and they're like, it's not working, and so something to be mindful of. Yeah. Cool. And yeah, Zookeeper, I'm not going to go here. You can, if you want, connect to it. It's typically not required. So yeah. All right, so cool. That's it in terms of the configuration and stuff. Now I'm going to go ahead and show you something, something working, something very, very primitive and sort of naive, but then we need to get that done first. So let's confirm if this cluster is functional and working. So let me go into an EC2 instance. It's sort of this Kafka jump box, so to speak. I have a EC2 instance here. I can connect to it using the session manager. And let's wait for this to come up. Okay, I hope the font is okay. Should be fine. If not, shout. Yeah, so what I'm going to do is run a very, very simple producer consumer demo. Remember the diagram I covered earlier? You have producers and you have consumers, right? Client applications, basic stuff, right? So what I'm going to do is, and I'll do a lot of copy pasting. Not good at typing now. I'm not going to put my fingers under stress and then waste your time. So what I'm going to do is actually first list down all the topics which I have. So I just exported this environment variable. That's all, nothing special. I'm going to run through this command very, very quick. This is the standard. This is not MSK tooling, nothing specific to AWS, Amazon. This is the standard Kafka CLI, which comes along with the standard Kafka installation. Nothing fancy here. And I'm running a script, this called Kafka topics, and I'm pointing it to the MSK cluster. In this case, it could be any other cluster for that matter. I'm giving it a configuration file. I'll talk about this a little bit later. I'm saying, hey, list all the topics. As simple as that, right? So it should work. And as you can see, there are a lot of topics. I have done my homework. I've prepared my demos. So obviously there are a lot of existing topics in this cluster, including orders and tests and whatnot. Okay, so that's fine. So what I'm going to do now is use this test topic and start a producer. Okay, so again, copy paste. I like copy paste. Everyone likes copy paste. So here I'm just using a console producer, again a standard Kafka CLI tooling, nothing else. So Kafka console producer, I say, hey, this is the configuration which you should use, and this is the topic I pointed at. Very simple, standard stuff. And once I see a prompt, now I'm ready to produce data. But before I do that, what I'm going to do is actually open another terminal session and have a consumer running as well. Okay, so what I can do is actually, yeah, I apologize. Just 1 second. Sorry for the background noise. Give me a second. Okay. Oops, sorry. I did not do this because I did not set the broker here. So I'm just setting the broker. So what I'm going to do is actually show you, yeah, I can show you all the data from beginning, but all I'm doing is using the Kafka console consumer, the CLI, to consume data from the same topic. Now I'll go back to the producer, just simple, hello. Oh, oops, I didn't want that. Hello, Mumbai. Typing properly. my UG. Yay. So these are like three different events or messages or pieces of data which I sent using the producer here, the CLI producer, and here you go. I mean, and you're able to see the consumer, right? Very very simple, like super 101. But then it is important. It's not exciting at all. I understand. I realize that, but it's very important to understand what I'm going to tell now actually to in terms of the pieces that you need to have for all this to work properly. Trust me, if you make a mistake, even this is not going to work and you're going to be embarrassed, like, and discouraged. So yeah, simple thing like this can be a nightmare. So what I'm going to do is now run you through everything that's required to get this sort of running, the IAM settings, the configuration, and so on and so forth. So everything you need for this simple hello world to work. Yeah, so there are two very very important things. So like I said, I am going to be using IAM authentication. I am using IAM authentication. Nice. Okay, so IAM authentication and connecting from an EC2 instance, which is this one right here, yeah, the one which you're seeing. And to understand this, right, the first thing is this EC2 instance actually has an IAM role associated with it. So I'm going to actually show you that real quick because you need to be able to connect the dots. Okay, so go into this EC2 instance and let this come up real quick here. So if I were to scroll down and you notice this IAM role, this is what is one of the two important points here. Now if I were to show you the permissions which are associated with this role, that is what is making things work at the end of the day. If I scroll down, there are a bunch of permissions. You can ignore the other stuff, just focus on the on this one, right? This policy right here and the bunch of permissions. Oh, sorry, not this one. I apologize, I clicked on the other one. So if you see, there are a bunch of permissions. I'm not going to like go actions and go deep dive because we don't have that much time. But these are like standard policies and permissions, nothing else. Now, what I can definitely do is actually open this up for you in the documentation and show you where you can go to refer to all this when you get started and when you're trying to make sense of things. Okay. So in the MSK documentation here, there is a section within the IAM access control section where you can figure out, hey, what does each of this action mean, right? And what does it actually do, right? It's description here. So you should be able to figure it out, right? This is all I'm using here. This is there in the documentation for common use cases, right? So that's one thing. And the second important thing is actually the security group rule. Now, if this is not present, the connectivity will not work in spite of you having all the IAM permissions and so on and so forth. Okay, so let me show that to you. I'm going to go back to my MSK cluster, and if I scroll down, just let me, I think bumps. This is a bit too much. If I scroll down and down, you see the security group right here. Okay, I'm going to open this. Okay, so this is one security group, and I have a security group associated with my EC2 instance as well, right? So if I go here, and if you see this security group, and if I were to open this, okay, and go back to the security group here for my MSK cluster and look at the inbound rules here. So if you notice this rule here, the last one, okay, so what it is saying is, hey, on port 9098, allow communication from this particular security group. Notice the last few characters here, 1412B8. If I were to go here and show you, this is the security group for my EC2 instance, right? So basically, that's how I've done the wiring. Okay, so two very, very important things. If you don't have this, things are not going to work. Okay, and coming back to the IAM authentication. Okay, so like I said, I'm using this plugin here, which makes it possible to use IAM with MSK because the default way of working with Kafka is something else. Okay, so if I were to go back to my systems this thing over here, and let me show you how things work. Okay, so I was telling you that I'll show you this configuration file. So there is a properties file, and look at the contents here. I'm going to bump it up a little bit. So if you see the security protocol which is being used, SSL, and I'm actually using a SASL mechanism called AWS MSK IAM. This is a custom SASL mechanism. Okay, and notice the class or the handler which is responsible for actually executing this entire process. It's within this MSK package. So basically what's happening here is this is all being run, or this is all courtesy IAM authentication plugin. Okay, so this is all courtesy of this jar file which I already have here, and I've configured it to I have pointed this. It is the class path for the Kafka CLI, and that's how it is working. Okay, so I'm going to actually open this. This is very important. Okay, because from a fundamentals perspective, sometimes people understand, oh, hey, you know what, we are using IAM authentication. Great. How it is actually being used? What is there behind the scenes? So I really want to deep dive into this real quick and show you. So this is an open source project, right? This is an IAM authentication plugin for MSK, and this is what I'm going to open the GitHub project for this. And I wonder what's taking it so long. It should not. But anyway, so yeah, okay, cool. So this is up and running here. So this is a very sort of important open source plugin. So this allows your Java based Kafka clients to use AWS IAM for authentication against MSK with Amazon MSK. Okay, so how does it actually work with EC2? How it's all how everything is working? If I will scroll down, you will see this part, right? So it is actually using the default credentials provider. So it'll do all of this, 1, 2, 3, 4, 5, 6. But in this case, what's working here is the instance profile credentials, because we are using EC2 in this case, right? You could have used, I don't know, EKS or something else. It's possible to work with that as well. But in this case, this IAM plugin is actually using the profile credentials, the role associated with that EC2 instance which I have up there, and that's the reason, right? This is all done via the EC2 metadata service. Okay, so this is how it works end to end for this configuration and stitching together and wiring all the different pieces for even a simple hello world to work, right? Because this is the foundation. Other advanced things are not going to work. Okay, so that's that I had in terms of this fairly involved demo. Like, yeah, although it's it was a hello world. Yeah, I can move on to some of the other stuff and pause for questions later. So I'll move through this real quickly because I think, yeah, I need to be cognizant of the time as well. Okay, so I'll wrap up a few other things before I move on to other topics like MSK Connect. Again, in terms of the AWS integrations, we are still in the features and foundations sort of section here. So like I said earlier, MSK is very tightly integrated with the rest of the ecosystem. I already mentioned VPC, showed you IAM. There is KMS as well, but MSK also works with AWS Lambda. I'll show that to you in the demo, not talk about it. There's integration with schema registries. In this case, there is the AWS Glue schema registry, the stream processing with Kinesis data analytics, and so on and so forth. And you can also use CloudFormation, actually, which is not a surprise, obviously. You can define your MSK-related cluster and resources as code. And not just CloudFormation, you can use AWS CDK as well. To define clusters in code if you wanted to, right? Using a proper programming language. So yeah, all that's there from an integration perspective, and of course you can scale at a variety from a couple of angles, actually, horizontal and vertical scaling. I think it's very common terminology. Horizontal scaling is when you add Kafka brokers to your cluster, like you have a 3-node cluster, maybe you want to bump it up to 5, and so on and so forth. And vertical is when you bump up the capacity of an existing node. But there are things to keep in mind when you actually scale out your cluster. Things like there's only scale up which is supported, and a bunch of other things. So I wanted to call that out so that you keep that in mind. And of course, you can scale up your storage as well. So there are 2 modes actually. There's this manual, and there is automatic, and you can configure some auto scaling policies for your storage as well, for your individual broker storage for MSK. But yeah, you cannot actually decrease the storage volume. Something to keep in mind. If, say, perhaps you want to reduce the size of your cluster again, you have to actually migrate to a different cluster which has a smaller storage. So yeah, I mean, definitely nothing is perfect. You have to keep that in mind. And observability, like all the services, MSK obviously it integrates with the CloudWatch. You can configure different levels of monitoring, like for per broker or per depending upon the granularity. But you can actually also integrate with open source solutions like Prometheus and others. I haven't actually tried this. I'll be very honest with you. I need to try out MSK with Prometheus in terms of some of the interesting stuff. But yeah, you can use it for again, monitoring and observability is built into the system from a service perspective as well. So I want to call that out. And I want to save this. I know I mentioned this earlier. So, and the thing with Kafka is that, again, there are 2 distributed systems when you talk about Kafka. One is Kafka itself, and the other is Zookeeper. But and managing it is very Zookeeper. It's a very brilliant system, but then managing it can be very tricky and flaky. But with MSK, the good thing is that, and I personally appreciate this a lot, is Zookeeper actually chugs along behind the scenes. You don't know about it. There is a cluster there, highly available. You don't even pay for it actually. So it's all behind the scenes. Yes, you can connect to it and all that jazz, but you don't need to really worry about that if you think about it in a way, right? So just to summarize everything in this section so far. So you have this quick architecture diagram for you. So you have the MSK service in a VPC, and you have your your VPC, right? MSK obviously running in the service VPC, and you have private subnets and VPC, and you connect to the cluster via ENI, and all the traffic in this sort of a setup travels within the AWS network, right? You don't leave the AWS backbone, but you can actually have public access, and this is something I want to call out if you wanted to. So when you actually create a cluster, the funny thing is that you will not be allowed to turn on public access, and this is by design. So you'll have to actually wait for the cluster to get created, and only then can you update it to make it publicly accessible. So that's that. And there are few preconditions if you want to allow or switch on public access, and you should understand this, right? Because and typically I want to call this out because if you see other services, a lot of other managed services for Kafka, competitors and so on and so forth, public access is sort of the default, to be honest with you, but that's not the case here. So don't be surprised. So for public access to work, you should have subnets associated with your cluster, and they should be public. And it's kind of a given. And obviously, they should have associated route table and internet gateway attached to them, right? So that configuration needs to be there. And there are a bunch of other things as well. And it's very well documented, to be honest with you. So, but something to definitely bear in mind when you think about, hey, I want to expose my Kafka cluster beyond the confines of my VPC and so on and so forth. Think about that. Okay, I'll pause here because it's important. I can take maybe one question and park others for later on. Let me know, Sanchit.
Sure. So the first question is, what's the difference from SNS, SQS, PubSub model?
Right. So look, right, SNS, SQS, and PubSub, they are all different. Like PubSub, good point, right? So actually, this goes back to one of my blogs. Okay, so Kafka is neither this. It's both a PubSub system as well as a queuing system. And just to give you a background to understand this, right? Queuing is all about load balancing between multiple workers. And PubSub, right? So you have a topic, and in a queuing setup, so you have say 3 consumers, right? And all the load will be balanced across these 3 consumers. Okay, when you have a topic-based system, what happens is, data will be sent to all the consumer groups, and each consumer groups will have different set of consumers in them, right? So it's a combination. So these combination of consumer groups and topics and partition it is what that makes Kafka this unique, give it this unique capability of working as a queue as well as a consumer as a topic, right? So it's actually in between both SNS and SQS, right? And from a service perspective, again, it's very different, right? Notification and queuing systems are very different than what you would get something like MSK or Kafka in general as well, right? So it's both sitting as a queue as well as a topic, depending on how you use it.
I think the follow-up question in that itself is, the data remains in Kafka, or it will be deleted once consumed like MSK?
Excellent. Yeah. So actually, yes, good point. It actually remains in Kafka, but that is something which you can configure. You can configure retention, right? That is depending upon. So I think the default for any, like if you go with open source Kafka, so your data is actually retained for 1 week. Okay. So that is something which you can definitely retain. And there are other things like tiered storage and sort of other bells and whistles, which you would get with fully managed services. But yes, it does remain in Kafka. And that's a big difference from, Kafka and things like SQS, or even people talk about comparing this with, other RabbitMQ and other queuing systems. It does not get deleted. Once the message is consumed, no, it is not deleted. It is there. You can actually replay the data within your Kafka topics. I remember I spoke about offsets. That is what actually makes it possible. So you can tell your clients, hey, you know what? Go to the beginning of this topic and replay or process all the data from there. Yes, you can do that. Or go to this specific offset, or go to this specific time within this Kafka topic. So all that's there. Yes, in Kafka. And that's what makes it very powerful and unique from a unique proposition perspective.
That's a very good question I can see in the chat is, so inside, this is from Sandeep. So in spite of using SSL _SSL,
Yes.
plain text works because it was enabled in the configuration of MSK. Is that correct?
Exactly. So you can have combinations, right? You can have multiple ways of authentication and encryption and so on and so forth within the context of one single cluster. Yes, that's right. That's why it's working for demo purposes, like I said earlier. Good question. Thank you.
One more question is, how would you
Yeah.
differ NSS compared to MSK in
First thing is, of course, the open source versus the those kind of debates. Yes. To be honest with you, I think this question is so open ended. It's actually not even. It's you have to think about your use case, right? Of course, there are pros and cons for everything. Open source with Kafka, you can. Sure, there is MSK, you can run it yourself and so on and so forth. You understand Kinesis. That's not the case. There are other sort of conceptually different features with Kinesis, right? In terms of, hey, my client applications, how does it run? In terms of its support and so on and so forth. So it's a very broad question. I'll be very honest with you. Difficult, almost impossible for me to answer unless someone tells me, and I'm being very sort of candid here, like, hey, this is the use case, and help me understand, right? So very difficult. But yeah, closed source versus open source is one of the obvious ones. Not a very heavy Kinesis user, I'll be frank with you, but then yeah, more on the open source side.
I think I can vouch in for
Yeah,
this one because
for sure. Yeah.
I had a long debate about this internally within AWS itself.
Awesome. Okay.
So this is a trend which I have seen, Kinesis versus MSK. And again, this is my personal observation. If a kind of a use case which is a newly developed on the cloud and
Yeah.
precisely on AWS, people will try to leverage Kinesis a lot because they don't have to do most of this thing, and which this new managed Kinesis, right, which comes out of it, you don't have to worry about the sharding and those kinds of stuff, which was
Yeah.
previously the. So
Yeah.
that's try to leverage the benefit and more focused on developing their applications and business use cases. Most of
Yeah.
the case adoption I've seen where people are looking to migrate from their open source self-managed version to the cloud managed version, because the kind of migration strategy is more, I would say, apple to orange, not apple to apple, but apple to orange, close to it. You don't have to modify lots of stuff there, and simply they can take care of
Yeah.
things. And Kenneth is more used for the people who wants to leverage streaming in their business application, but more focused on solving the business problem, like how they want to
Yeah.
consume the data, and not focus on real time on the fly processing the data. Because Kinesis is more like a streaming pipeline, which I use a lot in my layman language. It's a pipeline
Mm.
which will
Yeah.
allow you to load the data, but not process. You can use Lambda and you can process the data and those kinds of stuff. But
Yeah.
Kafka is much more mature that you can mask the sensitive data and those kinds of replay and stuff. So it's not just
Yeah.
the pipeline, but some
Yeah.
more processing along with that pipeline. So
Yeah.
that's a difference. And as Abhishek rightly mentioned, it's more about there are many options are available in the market, right? It's all about when you architecture it, you understand what puzzle or what block you need to fill in that
Yes.
puzzle of the architecture, and
Right.
that's what helps. But this is what my observation I have seen so far in the industry.
Absolutely. No, good point. And so, Sanchit, I think I want to call out the part around migration. That's very important. So you have Kafka workloads. Migration is a huge story, and actually that's actually covered by tools like Mirror Maker and other components within the Kafka ecosystem as well. But yes, if you are not into Kafka at all, you're not using on premises, or I mean, yes, you might, and you are entrenched within the AWS ecosystem. Actually, MSK works as well as with the AWS ecosystem as well. Kind of spoke about some of the things, but then yeah, if you don't want to, if you're not within into Kafka at all, yes, maybe something you want to think about. Yeah, Kinesis is something for sure. Thanks, Sanchit. Appreciate that.
I think there's a follow-up question. With MSK, we can configure stream. We can configure stream for exactly one message processing was introduced. With Kinesis, consumer
Yeah,
may deliver more than once.
yeah, exactly. Once is, yeah, it's you have to, yeah, I mean, it's a different discussion. Yeah, I will not go into the philosophical discussion. It is hard in distributed systems, but yes, Kafka does make it possible for you to configure that. You have to be very careful with your entire sort of your producer, your consumer part. You have to make sure you understand that, and it's not just on the server side, for your client applications as well. Say for example, you're using Kafka streams. Yes, there are configurations in Kafka Connect. Yes, there are, but you have to know what you're doing. So yes, if you want to depend on the promise of exactly once message processing, I would recommend, again, for personal thing, is rethink your requirements. Yeah, but if you are absolutely, you cannot avoid that at all, yes, be sure you do your end-to-end testing and understand what you're getting into. But yeah, if you can rethink your architecture, if it's tough. Exactly, once processing is tough. Yes, I'll tell you that. No matter what anyone promises in distributed systems. All right, cool.
The next one is, can we pull the data from RDS with MSK?
From RDS, yes, I have a demo for Aurora actually, but yeah, yes, you can do that. Something called change data capture. Yes, you can integrate.
I mean, that's the slide which is going to talk about. This section is going to talk about how you can do
MSK
that.
Connect. MSK Connect. Yes, I'm going to talk about change data capture and there's one definitely one use case. Any real time Kafka business use case. Yes, it is like I said, right? Kafka is literally it's a distributed streaming platform, right? So you want I'll give you a very simple use case. I'm going to show that to you. So you have a scenario where you have your existing RDBMSs, right? Old, new, doesn't matter, and you want to make sure, and of course you can say, for example, you have Postgres. Yes, you can sort of extend and it to search real-time search use cases. But if you want to use a specialized system for real-time search, so what you can do is set up this change data capture, piping all that data from your relational databases into MSK or into Kafka, and then have your downstream systems like, say, Elasticsearch, or there are other components as well, right? Bunch of real-time services, Lucene, whatever you want to use, to have that real-time search component within your applications, within your services, within your systems, right? You want to have your caches fresh, right? Like people say, right? Keeping cache updated, right? It's one of the two hard problems in computer science, right? Naming things and keeping your caches warm and hot, right? So you want to update your caches, maybe Redis, right? From all your other end systems. So you can integrate that with Kafka and make sure you have a pipeline in place where it updates all your cache in almost real time, and then your end systems can access that data. That's one very simple sort of business use case I'm talking about here. There are tons of others, right? I can talk about like industry verticals and scenarios like fraud detection and so on and so forth. A bunch of things. And you can mix and mash and integrate different services with Kafka at its core to achieve those scenarios. Cool. I'm going to carry on and save some questions for later if that's cool. Yeah, and I'll make sure that I keep in mind the time, because it is 11:30. Whoa, we have 30 more minutes. I can't believe this. Okay, so I'll rush a little bit. Okay, so I'm going to talk about MSK Connect, but it's a different area. But what I'll do is, before this, I will give you a very quick, very quick intro to Kafka Connect, much more quicker than I planned, because I got so many awesome questions. Now, Kafka Connect is actually a very important part of the overall Kafka ecosystem. Okay, so it's another open source solution that complements Kafka. So you have Kafka sort of, like I said, sitting in between, and Kafka Connect as this integration layer to stream data from one system to another. Okay, now Kafka Connect uses these things called connectors, right? That's literally in the name. Now, why are these connectors important? And why do you even care about them or need them? Because hey, you can write producer and consumer applications, right? With to integrate your systems. But imagine doing this for a variety of systems, for a variety of business use cases. Say you have a database or a CRM or maybe a proprietary system. There are tons of sort of services and systems which companies have and use. Now with connectors, what happens is typically you get this off the shelf capability. There are built in connectors for a lot of common systems, so you can, it's a plug and play model essentially to move and integrate data between systems. So connectors come in two flavors: source and sink. Source connectors actually move data from a system, from a source system to Kafka topics. Say you have a relational database, for example, like we just discussed, and a sink connector does the opposite, right? It's sitting on the other end of the spectrum. It moves data from Kafka topics to target destination system. Again, this could be any system, right? And I'm trying to explain this is in very simple terms, of course. But you can think of Kafka Connect is this JVM or Java based platform, and you can run sort of pre-written connectors, and that's one way of thinking about it. But the second way of sort of thinking about Kafka Connect is also, and it's an advanced thing, is it's also framework and library, because it allows you to, it gives you the framework and an abstraction to write connectors yourself, right? There are tons of open source connectors out there. For sure, you can use them, plug and play, boom, it'll work. But you can actually write your own connectors. So you have a in-house proprietary system, go ahead, Write a connector for that. Cool. Yeah. Okay. So that's Kafka Connect. It's great. It's awesome. I love Kafka Connect personally, working for it with it for a while now. But why do we need MSK Connect, right? Again, the same story. Same story. Kafka Connect is a huge platform, complex, distributed. You can install your connectors and have this data integration pipeline and fabric, but running it at scale is very challenging. You have to think about the infrastructure, HA, and reliability. So say you're running critical data pipelines for your company, and you wouldn't want them, say one of the connectors to break and not, getting updates from your relational database to your, search systems, which your users might be using to search products at the end of the day, right? So you have a new product, because your connector broke, it is not synchronized end to end. So you don't want that. You want to monitor the health of your systems, the health of your connectors, and that's where something like MSK Connect comes into picture, right? Fully managed Kafka Connect. Bring in your existing, connectors. MSK is compatible with most of the connectors, and rest is again the promise of handling everything end to end. Okay, moving quickly here. Now, before I move on, I think there are important terminologies which are very, very MSK Connect specific. They should be introduced before I show you something else. So in Kafka Connect, what you typically do in open source Kafka Connect, I mean, you install these connectors. They're Java applications. Think of them as Java applications. So they're jar files, or perhaps bundled as zip files as well, and you place them in a specific location. To be precise, it's within the class path of the Kafka Connect runtime, which is, like I said, a JVM process. Okay, but you cannot do that with MSK Connect. You can't, go and SSH, and you probably don't want to do that, right? You don't want to mess around with jar files, throwing them here in this system, that system, right? So it's a managed service. Yeah, it's access shutdown. But what you can do is create this. There's this notion of plugin. So what you simply do is upload a jar file or a zip file to an S3 bucket, and you configure that location when you create a plugin. And I'm going to show that to you, right? So first is plugin. Plugin is nothing. It's a pointer, so to speak, right? Pointer to S3 bucket where you have the jar file, which is nothing but your Kafka Connect connector. When you create a connector, you specify a plugin you want to use. Okay, and at the end of the day, there is the notion of a worker as well, which is not specific to MSK Connect. We call them workers even in open source Kafka Connect world, right? So a worker is a JVM process, nothing more, nothing less, that runs one or more connectors simply, right? So plugins, you have connectors, and you have workers, and typically this is what it looks like. Okay, so a worker sort of handles a set of tasks in parallel threads. I'm not going to deep dive into how you optimize these threads and so on and so forth. But at the end of the day, Java processor, there are multiple threads which are working in parallel to copy data and run your data integration pipeline. So these workers actually abstract the entire infrastructure for you. And in the MSK world, what you typically do is you define the worker capacity in MCU, or MSK Connect units. I think that's what it's called, MSK Connect units. So it's very, very typical of other infrastructure as well. It's a combo of CPU and memory, and that's how you figure out your total cluster capacity. So you have, say, 3 worker nodes, each with 1 CPU and 2 GB of memories, right? So that's how you figure out, right, number of workers into MCU for each worker. Okay, and it's elastic and scalable, so you don't need to worry about it. Like, if you configure MSK Connect, you say, hey, I want you to scale automatically, right? And I'll show that to you. So I'll not talk about it. I'll not waste time. So yeah, it's kind of seamless. You can have provisioning, auto scaling, or provision mode of your compute capacity for your MSK Connect, essentially. Okay, so time for getting this getting started demo again, for MSK Connect. I am going to switch here, and just give me a second if you don't mind. All right, so I have MSK Connect here. Of course, I have the console open. Connect is here, so connectors and plugins and workers, right? So I have, let me show you the plugins, right? So I have 3 plugins here, essentially 3 connectors, 3 different connectors, which I'm going to demo at different stages. DBZM, DynamoDB, and there's another source connector that I have. And let me show you one of these configs, plugins, right? If I open this, so you see this actually points to an S3 bucket. Nothing fancy, right? Boom, and this just has a zip file there, nothing else. Very simple. And if I were to come to connectors, I have 3 connectors up and running here. I had to do this because if I were to just wait, create a connector on the fly and wait for it, it takes a bit of time. So I don't want to, obviously I want to be conscious of your time. So I have 3 sort of connectors here, and each connector sort of ties in with a specific plugin. Okay, so I can actually show you this data gen source connector right here, because I'm going to use it very, very soon. Yeah. Actually, you know what? I'm going to. No, actually, I won't run through the process of creating a new connector. It's going to take much more time than I expected. So I'm going to run you through an existing connector. Now, what you are looking at here is a data gen source connector. Why am I using this? This is a very, very handy connector. Again, open source, pre-written, which you can use if you want to get started or try things out with Kafka Connect. Not just MSK Connect. To be honest with you, you can use this with open source Kafka Connect. Okay. So what it does is it generates random data, and you can configure it accordingly to your needs, and you can pump data into Kafka topics, and then you can test the rest of your pipeline or consumers and so on and so forth. So it's very, very handy, right? So this is the configuration. Each connector has a specific configuration which you can define. So this is the class for this connector. Of course, this class is automatically, all these components are pulled into the MSK Connect runtime, and the zip file and everything, the jars, all that magic happens behind the scenes. And I say, hey, you know what? There are different quick starts associated with this specific connector. So I've said, hey, you know what? Give me order related data, random JSON data. And yeah, that's a couple of important configurations. Very, very simple. Yeah, and I use this plugin which I showed you earlier for this specific connector, and of course I'm connecting this with the existing Kafka cluster. I have to point it to explicitly point it to a cluster. And I was talking about capacity as well earlier. You can have auto scaled or a provision mode. I have auto scaled here. So what I say is, hey, you know what, by default start with these minimum number of workers. You can go to a maximum of 2 workers and scale in, scale out policies. Okay, so these are the sort of thresholds. So below 20, scale back to 1. More than 80, scale to 2. In this case, it's 2. You can have a maximum of 10 workers, if I remember correctly. Yeah. So in terms of connector capacity, and that's pretty much it, right? And another important thing is, even MSK Connect depends on IAM roles. So I have a role configured here. This has the MSK Connect specific permissions again for this specific connector to be able to talk to MSK. Okay, so all that is happening within the with the help of those roles, standard stuff, which I actually explained to you earlier as well, right? And IAM authentication has been used behind the scenes because, again, this is using the authentication plugin behind the scenes. So let me test this end to end. So I'm going to go back and refresh this thingy here. And yeah, let me do my standard copy paste here. I set up my Bootstrap clusters, and what I'm going to do now is consume data using the, using the CLI consumer. I will consume data from this topic called orders. Okay, so what's happening is, behind the scenes, that source connector is already pumping random data. The connector which I have running, it is pumping JSON data into these topics, and I've just started a consumer to receive that data. As you can see, right, it's come up here. So this is random. This like, I've chosen orders. It could be users or clickstream. There are a bunch of options there within the connector, right? So, and yeah, you can test this out. Very, very good way, very, very handy way to get started. I always use it all the time since the beginning. So yeah, very, very simple sort of end-to-end thingy, right, where you have a source connector and you have a consumer here. Okay, now let's move on to something a little bit more advanced. I spoke about that scenario of change data capture. Very, very important use case. I'm going to go back to my presentation real quick here, and I want to cover this because it's super important. So building this end-to-end pipelines. Okay, so we have this on one side. I have a MySQL database. It happens to be Aurora. It could be RDS, or sorry, it could be any other database on AWS, or managed, not managed, doesn't matter, as long as you have the configuration set up. It could be Postgres as well. And then in between, we have something called a connector called Debezium Source Connector. Debezium, open source project, one of my favorites. I've worked with a lot, even contributed to it. I love it. Very, very handy set of connectors for a variety of databases. Okay, so I have Debezium MySQL Source Connector, which is capable of extracting the changes in real time happening in this MySQL database in this case, or for that matter, any relational database. And once this data is in Kafka, we can do what we want, right? We can use another connector, as you can see, a sync connector, maybe to pipe that data to a DynamoDB table or something else. Okay, but before I go into this demo, I also want to touch upon this topic of change data capture, because it may or may not be new to you. I don't know, but I'm going to cover that anyway. So if you haven't heard of CDC or change data capture, that's okay. Just to put things in perspective for you. So typically the way you interact with database, right? It's through its query language. So SQL or Cassandra has CQL or MongoDB has its own query language and so on and so forth. So, but these are different. But every database, the common thing across all the databases, almost all the databases, is this notion of logs or write ahead logs. And what they do is they can be used to capture changes to data in tables or schemas even before they are actually committed. Okay, so for example, if you've used MongoDB, or maybe if you've administered MongoDB, you might know about oplog or this transaction log within Postgres, or a bin log in MySQL, or a commit log in Cassandra, right? Common sort of theme which runs across excuse me, all the distributed databases. Now, what change data capture does is sort of turn things around when you compare to the standard process of just querying data. Hey, give me this data, select star from blah blah blah, right? That's not the way, right? It turns things around. So you don't call the database, you don't say select star, the database actually calls you. That's what change data capture actually makes it makes it possible. Now you don't call the database, it calls you. Is I didn't excuse me, coin that term. It's actually this talk by Martin Kleppmann, and he spoke about turning this database inside out, right? So I highly encourage you that if you want to understand a bit more about change data capture, I'm not the right person or the best person for that matter, although I love change data capture and the concept and I'm well versed with it. Check out this, pretty much anything which Martin Kleppmann has written about distributed systems and databases. You can check this out, and I think you'll learn a lot about change data capture and how it's related to distributed systems. But I don't want to digress. A topic I love, so I can talk about it. But what I can do is, excuse me, I don't want to go there. I did not want to go there. I want to go back to my demo actually, and I will do that. If you give me a second here, okay. All right, cool. All right, so I want to show you the second connector which I have actually. Go back to connectors, and this connector called MySQL Debezium source connector. Okay, so again, don't worry, don't let this configuration intimidate you. Every connector has a configuration, every connector documents it, right? All you need to understand is we are using this MySQL connector. We are talking to a MySQL instance on Aurora. Where is the excuse me, this one, right? You see the database hostname, and yeah, so this is the connector configuration. I'm talking to a database here. And yeah, the rest of the configuration is very simple. So let me show you this, right, as to what's going to happen. So I'm actually going to pipe data changes to data from a particular table within the MySQL database. Okay, so let me actually log into that MySQL instance from this console real. Excuse me. Yeah. So let me. So this is my Aurora endpoint, and I will continue to copy paste because I don't want to waste your time. And yeah, very simple actually. So I'm using the sales DB database, and it has a table called sales order. So as you notice here, there are 29, just a little over 29,000 rows here, 29,000 plus 6 rows. Okay, so these are the number of rows in the database table as of now. Now what I'm going to do is go back. And check one of the topics, because this connector is already up and running. You will see that the data is already there in Kafka topics. So I'm going to show that to you real quick and talk about that as well in the process. So what I'm talking about is this process of first time data reconciliation, right? So you ran a connector, you had some data within your existing database, and I run a consumer. And from this topic naming is actually decided by the connector, sort of based on a configuration which we have. So what I'm doing here is you'll see this running for a few seconds actually, because there are 29,000 rows in that that table which I just showed you. And what has happened is, when I started this connector initially, when I created this connector, all this data got piped into this single Kafka topic. And if I were to close this, you will see that it has processed a total of 29,000 plus something messages. Okay, so this is this part where we talk about the initial data load. Okay. Excuse me. Now I'll talk about the second half of the data pipeline. Okay. Now that is responsible for taking data from MSK topic to this DynamoDB table with the help of the DynamoDB sync connector. Okay. So I'll show that to you real quick as well. I'll not go into the details. So I have the DynamoDB sync connector as well. And all this, by the way, this is all in a blog, so you don't need to worry. I'll call that out later. Don't worry about it. So you won't miss it. So yeah, it has a different set of configurations and all that, and it has a table as well where you'll be able to see the data. If I can go to DynamoDB actually. So you see where have I mentioned the table? Yeah, so this is the table name format. And if I were to go back to go to DynamoDB here, this is my DynamoDB this thing. So this is the table I'm talking about. So this is where the sync connector actually pipes that data. So the pipeline is my MySQL database to Kafka topics to using the source connector, and the sync connector actually pipes all this data in real time to this DynamoDB table. Now, if I were to go into this table, just decrease the font a little bit, and if I were to say, hey, give me the live item count here, you shouldn't do this a lot because it scans the entire table. But if you see, there is the entire sort of pipeline is clean as of now, right? So 29,006 records there, the same in the Kafka topic, and the same in this DynamoDB table as well, right? The initial data load is clean, nice, done cleanly. But what about incremental? What about real-time data synchronization, right? So we can actually continue testing this. Okay, so if I were to say, for example, go in and uh, insert some data, perhaps let me again, I have that query, I don't type it out all one by one. If I were to go here to this console and say, hey, insert about like 5-6 records, I guess. Okay, so I inserted this data into the sales order table. Okay, if I were to go here and see, I did not actually run this. So let me show you the Kafka CLI as well. I'm going to remove this part which says from beginning, because I don't want all the 29,000 records. Oh, well, you know what? I actually can't. I should have showed you earlier, but that's fine. Don't worry. If I were to go back to the DynamoDB table, hopefully everything has worked end to end. If I were to scan this again, you will see, oh, it hasn't. Okay. Let me check 1 second. Let me check the this thing again. It's fine. Let me run the entire pipeline because it should be working. All the rows got inserted, and let me see. I will run all the entire. I should see more than 29,006 records. If not, demo did not work. It's okay. You can always recreate this. It's fine. The entire scenario, so that shouldn't be a problem. So if you see, yeah, I inserted order ID 29007, if I remember correctly. Yeah, 29007, 8, all till 12. So if I were to go back here, you see these were actually inserted here successfully. I think the pipeline is still working. So all these order related information was sent from the MySQL database, that sales order table, to the Kafka topic here. All these 6, these are brand new, right? And I can actually close this consumer, and I can perhaps try it once again. Scan again. Oh yeah, now you see, right? 6 more records, 29 or 12 records, right? So the end to end. So essentially, of course, this is a demo, right? This from a business case or a scenario perspective, your any workloads might be working with your your relational databases, and the entire data will be piped. Now the beauty here is that it's not necessary for this one-on-one coupling, right? This is not like one way of doing things. You have the data in the Kafka topic. You can actually branch out to another. You can have the Elasticsearch sync connector and pipe the same data, maybe massage it a little bit. You can configure to sort of how to reformat that JSON data and so on and so forth in a way that Elasticsearch can accept, and you can run your real-time search queries, right? Because again, with DynamoDB, it's not custom built for real-time search, right? It's more for your real-time sort of OLTP applications and your standard applications and so on and so forth. It's a scalable serverless database. But again, horses for courses, right? So not just the only way of doing things, but I am showing you something simple from an end-to-end use case or scenario perspective. Yeah, cool. I'm kind of done with this section on MSK Connect. What I'm going to do is I have 10 minutes. Okay, and I still have a bunch of data, and which is sort of bunch of material here around MSK serverless. But I will pause here, and Sanchit, I will actually leave it to you and the other folks. Like, do we want to talk about serverless, MSK serverless, real quick here, or we want to take some questions? I'll because I want to be cognizant of the time as well.
Yeah, I think from a question standpoint, Abhishek, we only have one question on the pricing model for MSK, which some or other we will also see in serverless. So
Yeah.
my vote would be for the serverless stuff. That's a cool thing.
Yeah, sure. Let's go there, and I can definitely cover the because MSK pricing is not a big deal. You can search MSK pricing. I can show you right now. Cool. I'll move on to MSK serverless then. Thanks, Sanchit. Appreciate that. Awesome. So we covered MSK Connect, but again, serverless was built with certain feedback which we got from customers. Things like, hey, we have peak workloads. We have MSK provision. We have like 3 nodes, for example, and we want to scale out and shrink back again. Those kind of feedback. And of course, this is related to the topic of cost and pricing. You don't always want to run a 7-node cluster. Perhaps you want to come back to your original 3-node cluster, save some money there. And of course, there are other things, nuances when you scale out your Kafka cluster, things like partition management. You have to go through some manual processes. Again, things are not perfect. So these were some of the things which customers were definitely looking at, and hence the birth of MSK serverless. Now again, think of this is a different cluster type for MSK, right? One is the one which you saw was provisioned, the other one is serverless, and this obviously makes it possible for you to run Kafka without having to again think about cluster capacity and things like costs, perhaps, right? It will do the heavy lifting to sort of right size your clusters and scaling your cluster when you get the peak workload, and then scaling back in, right? And serverless actually has a throughput based pricing model. I tend to not talk about the pricing aspect a bit, but the promise of serverless in general is you pay only for what you use. Yeah, that's the promise of serverless. But I want to talk about one important thing before I move on to features and the demos and so on and so forth. Why? And I expect some questions here, right? So I'm going to cover this now. Why, like, MSK provision versus MSK serverless, and when to use what? Very complicated question, depends on your use case, but there's some sort of obvious things you can think about. So for example, if you want very, very tight control over your cluster capacity, your configuration, definitely go with MSK provision, the one which you just saw, right? You can have X number of brokers. You can also sort of tune in the configuration. If that's not what you're looking for, you can pretty much offload all that and use something like MSK serverless. Okay. If you have unpredictable workloads that have sudden spikes, say for a few hours, right? You have sales and this and that and whatnot, and then you want it to go back to normal, say a 3-node cluster or whatever, MSK serverless will be a better choice, because in terms of cost and operations, because like I said earlier, the scale out is there, the scale back in is not something which is there, which is a little bit of a handicap for sure. So MSK serverless is going to work well there. And there might be a situation where we don't know much. We are, say, thinking about a greenfield application or a service or a system. We don't know a lot about the workload. I think you'll be better served working with something like MSK serverless there, rather than get constrained from a capacity perspective, right? So just a few ballpark figures and estimates and scenarios where you might want to think about serverless. So I'm going to run through the rest of this real quick because I want to show you the demo. Again, very simple demo, but yeah, there's this on-demand streaming capacity serverless. Think of it like a utility, right? So with each serverless cluster you have about 200 Mbps of write capacity. It's all fixed. It's fixed, the write capacity. And 400 Mbps of read capacity from an overall serverless perspective, cluster perspective. And there is some partition level allocation as well for each partition. So there is, it's limited to 5 and 10 Mbps for write and read respectively, right? And that's very, very clearly specified when you actually create and see a serverless cluster. I'll show you. And yeah, the total cost of ownership, people talk about cost, right? It it closely follows your usage, right? So you tend to pay, actually, to be honest with you, I had a pricing slide and I can activate it. You know what, people are interested in pricing. I don't typically like talking about pricing, but you know what, I can activate it right here because we are talking about that. And don't count me on it, it may not be updated, so you check out the this thing, the website. But then yeah, it's very close to, you have this base some base cost per cluster, and then you have the rest, right? Data in, data out, you pay a bit for storage. So it's sort of split out between these different components, including the nominal cost which you will pay for sure, right? So that's how pricing works with MSK serverless. Okay, again, not diving too deep, just going over it real quick, because you have these different components which you have, right? And these might differ a little bit from region to region and so on and so forth. So don't quote me on that. And yeah, bunch of other good stuff, right? The very important thing is auto partition placement, because once the scale out happens behind the scenes, all that is taken care of. It doesn't happen with MSK provision. So customers were critical about it, and that's why MSK serverless. Okay, and all the other things are pretty much same as the other flavor of MSK. The compatibility with Kafka, the security. Actually, the security differs a bit. So with MSK provisioned, you have IAM as well as the Kafka native username and password based authentication. MSK serverless actually just has IAM, no other bells and whistles. It doesn't give you too many options. That's it. Just use IAM and be happy, right? And the other things are same, high availability. And the thing is that you actually don't know much about it, right? So that's why there's this blank sort of a thing. It's just MSK serverless, right? There are no brokers, which I have pointed out to, just your client application. So it's this facade or this abstraction over all your infrastructure, and it's just one. I think it's just one endpoint you think about at the end of the day, and your read and write capacities. Okay. So I just zoomed through real quick, again, being cognizant of time. I don't have a lot of time. I want to show you this demo because, in terms of, excuse me, sorry, I shouldn't have, I just want to talk about this a little bit and show you this architecture as well. So yeah, this integration between Lambda and MSK serverless to, serverless solutions, of course, right? So you can imagine the power it gives you. So essentially, there is native integration. So when you send data to a topic in MSK serverless or MSK for that matter. Actually, MSK also integrates with with Lambda. I'm just showing you two, serverless and Lambda, right? So it's a good topic to talk about. So yeah, you can have Lambda respond, as a trigger, so to speak, to in response to data being sent to topics within MSK serverless. Okay, so you can build a variety of solutions without thinking about scale and capacity and so on and so forth. So great promise. Let me go back to the console and walk you through all of those things. And actually, I don't have a blog for this. I am working on it, so you'll have that soon as well. So let me show you that MSK cluster actually very quick. This is the cluster, as you can see. It'll open up. Not a lot of bells and whistles here. Even if I were to go into the properties, I mean, yeah, all this network settings is the same actually. To be honest with you. And you see this write and read throughput, right? Very transparently mentioned here. This is the max capacity for now. And this, if I were to click on this client information, nothing much. One simple endpoint to connect to, boom, nothing, right? No different set of endpoints for different protocols, and just one endpoint, boom, plug and play. That's pretty much it. Okay, so let me go to my lambda function now. Lambda, I should have had some, yeah, and show you the MSK consumer which I have here. And as you can see, this trigger is defined right here. This is an MSK serverless trigger, and if I were to scroll down a little bit, this is the trigger which I have defined. If I were to show you the configuration, it's very simple actually. If I were to go to the edit section, I'll show you the existing configuration. So yeah, all I did is point to an existing cluster, MSK serverless, and I said, hey, you know what? Okay, this is the batch size, which is the maximum batch size which can be sent to this particular Lambda in one shot. And I say, hey, just consume data from this topic. So yes, this topic needs to be pre-created in the MSK serverless cluster, just FYI, and only then can you specify it. Otherwise, it'll throw you a bunch of errors. And it also uses, behind the scenes, everything works on basis of roles and IAM, right? So as you can see here, this it's very clear. So in order to read from the MSK trigger, for this Lambda to get triggered from MSK, your execution role, the Lambda execution role, should have proper permissions, right? So I can show you that role now. If I were to go into permissions, and I'm walking quick through this because due to paucity of time, I have this role here. This is where I've configured, how it works with this connect. So you see, right? So it's connect related permissions. You can go and check that out. And this works with the serverless cluster, which I'm working with right now. So that's that. And I need to show you some other stuff as well. Yeah, so the permissions is here, and the VPC. Okay, VPC is super important. Like I said, just with in case of the EC2 instance as well, this Lambda needs to be associated with the same VPC as my MSK serverless cluster. So if I show you the cluster here, excuse me, sorry, I clicked out of it. And I go to this thing here. So you see the subnet and the security group here, right? These three subnets, they are the same. as the one specified in Lambda. So you have, these three private subnets, and the security group is already configured. What I did here is, just to make this easier, I used the same security group, so that I'm just lazy. I did not configure additional security, the inbound sort of rule. So it's going to run seamlessly because it's the same security group as my MSK cluster, serverless cluster. So this is going to work. Okay. And yeah, that's pretty much it in terms of the configuration. There are a few other small things. I am not going to bother with that. It's okay. It's fine. Yeah, and let me now show you this. Hopefully it works. It should work. It shouldn't be too much of a problem. So what I'm going to do is set up, or just now here, if you notice, I'm using my serverless. This is the MSK serverless cluster, and I'm going to do is show you all the topics here. I just have one. This is not the same MSK cluster I was using here. I just have one topic here. This is a different cluster. This is the test topic, and what I'll do is I'll simply start producing data to this to this topic. Hello, not hello. Hello, Mumbai, UG. Okay, and how do I test this? It's very primitive. I apologize, but because it's a very, very simple demo, I'll go back to the Lambda and actually just show you the logs. Just for this case. Obviously, the logic could be super complicated, and you could write all kinds of data processing and all that. But right now it's just that, and you see this one right now. I think this just came in. Yeah. So yeah, this is the one which the messages which were just received, right? I can actually show you the code if you want me to, just in a second. But yeah, very simple. The end-to-end thing is working. I could have made this a little bit more advanced and maybe 300 level, but I did not, to be honest with you. So yeah, we received an event from offset 13 in partition 1 for this topic called test, and I received the message called hello, the one which I just sent through the producer. And hello, Mumbai, UG. I can keep sending and refreshing, and it's going to work as expected. And let me actually, what, I will show you. I have this open. Let me see if I can. Oops. Oh, okay. Just give me a second. Sorry. I'll just quickly show you the code. Very, very quick. I have this. I'll have to drag it here because it's very simple. I have some Go code here written, so I might as well show this. Okay, yeah. So very, very simple. This is the Lambda handler which I have here. Again, this is Go code. I know. I mean, if you're not a Go developer, that's fine. The same would apply to Java or .NET or Python. So it's receiving something called a Kafka event. In this argument right here, and all I do is this. Very, very simple. But I could have code here. Actually, I'm going to the blog post which I write for this is going to have code for DynamoDB, perhaps some other systems as well, just to show that end-to-end system working properly. So yeah, this is the log which you saw event from so and so offset and so partition, and we received this message. And if the key, in this case the key is null, I did not send any key, that is why this part was not printed. But if the key was not blank, you would also see the key printed out there. So super simple. But yeah, what I wanted to go through was the wiring and the kind of things which you need to make sure for this to work. Again, I have when I was new to this at a point, right? And yeah, I had to make it work, and things are always not that apparent and easy, right? So yeah, that's it. A quick recap. I know I've gone over time. I apologize, but this is what we covered. There are a bunch of other things actually. Don't worry, you'll get these slides. You can actually work through some of the workshops and look at some of the other use cases. I know you mentioned, some of you had questions around use cases. So there's clickstream analytics, and we spoke about migration. Sanchit, you mentioned a very, very good point, and how you can actually use Mirror Maker. So it's all there in a very, very good workshop covering a lot of use cases, bunch of resources as well, documentation, the plugin which I spoke about, the MSK related blogs on AWS, official AWS blogs. And yeah, that's it for today. If you have questions, or feel free to chat, feel free to reach out. I know we have gone over time, but I'm available. I'm highly available on Twitter, GitHub, LinkedIn, wherever. So yeah, and happy to take other questions if you want to. If not, please, I request you to, and you may have seen this with other sessions, of course, right? Very specific, very common with AWS, with the DA folks here. Just take out your phones, scan this QR code, and give me your feedback. I would really appreciate that, not only to fine tune my content, but also in terms of our services and products, right? We really, really appreciate and value your feedback. So please do that. And once you finish it, you will get a link to download this presentation. Otherwise, it's on speaker deck. You should be able to search for it as well. But then, yeah, just a little thing for you. But yeah, hopefully this was useful. I'm gonna wrap up here, Sanchit, and come back. We have gone over time, but I'm happy to take questions, or maybe some other time. That's fine as well.
Yeah, I think audience, if you have any other questions, please put
Yeah,
in
feel
chat.
free. Yeah, if you have a little bit more time, it's okay. Yeah,
Yeah.
before lunch, or happy to chat. I think I made a mistake by putting on the slide. I shouldn't have done that. I apologize. If you are looking to scan this thingy, please do that. In the meanwhile, we can chat. I see a few. Sagnik says thank you, Sagnik. Appreciate you joining. I see questions. Yeah, I guess that was Sanchit. And I see Sandeep. Thanks for chiming in. I know looks like you have been answering a few queries as well. Thanks, Sandeep, for that. Kafka helps decouple producers and consumers. Each can consume at its own pace, and Kafka acts as a messaging pipeline or a backbone. Yes, that's absolutely right. I see some of the good discussions. Yes, MSK Connect is like pre-built producer API. Yeah, MSK Connect is not the API in itself. Yeah, Tosif, MSK Connect or Kafka Connect in general, it's more of a platform, right? So think of, let me simplify this. So it's this JVM process. You start a Java application, right? Maybe you have worked with Java application servers. It is a Java process, right? And then there is a way for you to install connectors and these other components on that Java process. I'm not going to the depth of that. Kafka Connect gives you a REST API to install connectors. So basically, these Java processes run, this Kafka Connect runs another set of Java processes, and so on and so forth, right? So a very simple way of looking at it is Kafka Connect is actually a platform, and you run your connectors. That's a much more logical way of looking at it. And MSK Connect happens to be a managed way of running it. That's all, right? Kafka Connect is open source, very core part of the Kafka ecosystem. So yeah, but thanks for popping up these comments. They trigger these conversations, so appreciate that. Yeah, and I think before this we have covered, because I see this comment from Sankara, which I covered, a real-time Kafka business use case. So I hope that was useful, because I spoke about the clickstream scenario as well, and the migration which Sanchit touched upon. Yeah, and I think all in all, the thing with Kafka is that, hey, it's open source. I'll be honest with you, it can be a little intimidating in the beginning. Okay. And that's from the point of view of, if you are getting started with Kafka, if you're interested with it. I have had feedback, and because I've been working with Kafka for a while, I've had experienced folks reaching out to me, like literally, and hey, you know what, I want to use Kafka, I want to learn about Kafka, because this is becoming the center stage in my company. We are going to pivot to it, and most of the companies have already pivoted to it. So it'll be surprising if I don't see Kafka as this, as this backbone, or that data infrastructure, or that data fabric within a company. Of course, there are a lot of other sort of tools and ecosystem components, and also this thing about, hey, that Kafka, it's big data. Sure, it is related with the big data ecosystem. It is very, it is in the front and center of big data, sure, but it is not just that. I'll be very honest with you. You can run a small Kafka cluster. That's fine. You can run a small MSK, the Kafka Connect cluster. Not talking about AWS or MSK or MSK Connect at all. Just Kafka, right? The way you want to run it. And you can run your microservices based on top of it. You can run these change data capture solutions to trigger your microservice, to power your microservices solutions, and so on and so forth, to power real-time indexing, real-time search, right? So just don't think of it as this, hey, it's big data. That's it. No, that's not the case. It has very important use cases in this microservices related applications and that domain as well. Many people, if you research things like change data capture specifically, you will see other discussions popping up. You will see domain driven design, lots of other things. If you look it up, you can again read up on content from experts like Martin Kleppen and Gunnar Modeling. They're excellent folks who have been working on these projects, and how and what kind of contexts and business scenarios you can apply Kafka or Kafka Connect and other sort of things. I see another question. But I'll stop here, Sanchit, because I don't want to keep on rambling. But I see a question from Tausif here. So yeah, can we have multiple tasks for parallelism? Yes, there is actually a configuration. I don't know if you noticed, but pretty much it's a common configuration in every Kafka connector is max tasks. So essentially what happens is you can configure those number of tasks, and even a task is another way of, or rather an abstraction over the number of threads, because as a user maybe you don't want to get sort of I mean, people do tend to get into it ultimately if they want to run it in a very very optimized way. But again, task is another sort of abstraction over the number of threads and to drive parallelism, like you mentioned, Tosif. Good, excellent point actually. And you can read up on the Kafka Connect documentation. It gives you a very very clear description in terms of the architecture, the deep dive. If you just search for Kafka Connect, you'll go to the Apache documentation, and it's very very well documented in terms of what is the granularity you can, and how to configure and optimize your Kafka Connect pipelines and tasks and connectors and so on. Thanks for raising that. I think it's 12:11. Yeah, and like I said, I would really really appreciate your feedback, and let me know, Sanchit. Yeah, when we want to wrap up, I'll leave that to you and the folks here and the audience. If you have more questions, I am more than happy to stick around. I don't have concerns. Yeah, I'm fine with it.
Yeah, guys, I think we'll wait for a couple of more minutes. If you have any questions, please put in the chat. If not, then we'll call a wrap. Yeah, I'll share the LinkedIn profile for Abhishek. I think.
So, yeah, for sure. I think should be able to help. One second. I really appreciate all the good questions, nice questions we had. Kinesis versus Kafka, and now about Kafka Connect and serverless, and the pricing, of course, right? And yeah, I want to actually MSK. You folks are asked about MSK pricing, right? So one second, let me. It's very simple, like rather than I get into pricing, but sometimes I don't, and I don't have the accurate numbers sometimes. So I don't want people. We all want to make money, so to make sure everyone has the right information as far as pricing is concerned. So you can pop it up, Sanchit, if you don't mind. Like, yeah, just in case. It's just very simple. Like, I don't even need to give you, if you search for MSK pricing, should come up. Like, again, it's based on what kind of broker size you're using. Is it T3 small, or is it 24x large M5 instance? So yeah, that it's based on price per hour and so on and so forth. And of course there are other components around storage as well, and so on and so forth. So yeah, bunch of things for you to consider, and something which I definitely want you to sort of pay attention to, rather than me zooming over it in a flash. I don't want to confuse you folks. So yeah.
I think there's one question.
Yeah, I just noticed. Yeah, just a bit of overview on Kafka streams. Yes, I didn't go over it because again, as it is, it blew out of proportion, right? So, good question. Thanks for bringing it up. So, Kafka streams is actually a very very important component of the entire open source Kafka system. So there's this. So if you talk about the ecosystem, there's Kafka the broker itself, Kafka Connect, Mirror Maker, and Kafka Streams. So what Kafka Streams does is it gives you this ability to do real-time streaming, streaming pipelines on data within Kafka topics. Now, at its very, very core, it's very simple, nothing fancy. It's this piece of Java library which you have. Okay, it's this piece of Java library which you can include as a dependency within your Java applications, and then run these. You might have heard of these terminologies called DAG, right? Directed acyclic graph. So basically, it's a set of tasks which you write code. It's all in code. It's not SQL queries as such. So it's all code which you write within your Java application as a part of your Java application to define your pipelines. Let me give you an example. The simplest hello world Kafka streams thing. I have data flowing in my Kafka topic called a test Kafka topic. Maybe I have words which have length more than 10. Just again, a random, very, very simple example. So what I'll write as a part of my Kafka streams application, that Java application, is I'll use a method called filter. Okay. Filter all the words which are more than length 10. Okay. Filtered. The next thing I'll do is maybe I will, I don't know, remove hyphens from some of the words. Done. That sort of filtration is done. And finally, what I'll do is I'll pipe this filtered data, this cleaned data into another Kafka topic called XYZ, whatever. So this is a very small and simple pipeline, so to speak, but you can define that in code that will run continuously on that infinite set of data which is coming through within your Kafka topics. This set of actions and these set of Kafka stream sort of acyclic graphs of tasks which you have defined, it's going to keep on running. And at the end of the day, it is just this beneath the hood, it is using producer and consumer libraries. But on the top, it gives you this abstraction of this stateless and stateful operations, right? Stateless like filtering and mapping, um, and a bunch of other operations like easily piping data from one topic to another, right? Those are stateless operations, or maybe even debugging or printing data as it travels through your Kafka topics. And a stateful set of operations, I want to do aggregations. Say for example, I don't know, I'm analyzing clickstream data, okay, and for various products, for example. So I want to group it, the simple SQL operations, right? They have this mapping there within the Kafka Streams world as well. So I can group this data by each product and aggregate that in ways I want to. Maybe I want to calculate a moving average, and so on and so forth, right? So basically, again, to simplify it, Java library to run these stream processing applications using a very opinionated library, right? It's not like general SQL which you can run using. No, it's a set of Java libraries gives you methods and operations which you can execute. And let me pop in this link real quick here. Again, just give me a sec, okay, to the documentation, and maybe you can help me run this right from a concept perspective. So this is very useful, folks. Yeah, thanks for bringing that up. Again, I appreciate that. Good question. Yeah, again, it's I can't go to everything. I remember giving a bunch of Kafka Stream talks in as early as 2017. I remember, yeah, super piece of technology if you want to go beyond writing just producer and consumer applications, or beyond using connectors to define your data pipelines, right? It's another addition on top of that. Interesting story. Personal story is I started using Kafka Streams. It came out in 2016, if I remember correctly. I never was a fan of Spark and Spark streaming. So when Kafka Streams came out, I was like, now this is my sort of answer to everyone using Spark streaming. I was never a fan. I found it very hard to wrap my head around the library. But Kafka Streams, when it came, I'm like, wow, this is meant for a Java developer, and it's sort of, yeah, it was lovely. I loved it, and I still love it. Yeah. So that's my personal story. I don't know about you folks, of course. Happy to hear from you as well. So yeah, I have had many heated discussions about hey, Spark streaming and Kafka streams, and you'll see a lot of such discussions as well if you try and deep dive into this topic. Real time data streaming is a very interesting topic in itself. Yeah. Oh yeah, I am. I am a fan for sure, Tausif. Yeah, I've been like I said, yeah, I'm a fan of distributed data systems in general for sure. Kafka, been doing a bunch of things around it since a while. Yeah.
So, yeah, I think it's time to wrap now.
Yeah.
And yeah, if you have any other
I
questions,
guess.
we have pushed.
Yeah.
I've just shared the link in the chat. This is the LinkedIn profile of Abhishek. Uh, we can all see that he's been very energetic. It's over an hour. Still, we don't see any drop in his energy level, and that's really true. I've spent good amount of time to host this session in the back end with him, so I've never seen his energy going down ever. So
Thanks.
trust me on for that one. So yeah, you can reach out to him for any other questions. And yeah, as I said, thank you so much, Abhishek, for spending your time from the weekend to talk about Kafka. And yeah, I hope we can see you more in User Group
Oh,
Mumbai
yeah.
to host some
Oh,
other
yeah.
sessions
Absolutely.
about
Yeah.
data analytics. And yep,
Absolutely
thank you
happy to be part
so
of that.
much. Yep. Thank you so much to
Right.
the wonderful audience. As usual,
Yeah.
you never let me down by asking too much of good questions. And I promised Abhishek, with that
Yeah.
promise, he was here. If you're going
Yes.
to ask some good questions and challenge me, then I'm going to join. And I think you guys made my mind. You never let me
Yes,
down.
thank you.
So
Yeah.
thank you so much, the audience. And yeah, I think Tosha, if you were talking about the session will be at 9 p.m. IST today. You can follow my LinkedIn handler where there are details about the airflow, and that is also going to be an interesting topic. Similarly, what's an Apache Airflow, how it's a managed workflow orchestrator from AWS. So we're going to
Yeah.
continue the same story, how open source help us to learn and how the managed service can help us to solve more business problem on similar lens. So you can follow my LinkedIn handle where I have this detail about the session. It's 9 p.m. today in the evening. So that's pretty much from this session. Just for the audience, there are a couple of interesting events which User Group Mumbai is going to launch. I know there's a vacation time, there is reInvent, Thanksgiving, Christmas on the table, but I'm not going to talk about what those events are. But do follow Mumbai handlers. I would really say there are good goodies out in the door. So please do join and follow us. You can think of next week itself. We are going to announce two events which are offline, and there is one more event which is going to come up next one after the reinvent. So follow Mumbai User Group, and if you have any questions, please reach out to Abhishek and me. We'll
Yeah.
happy to pick it up.
All right, awesome. Thanks so much, Sanchit, again for having me. I really, really appreciate that, and yeah, good that we have had that conversation. And yeah, now I'm here and got to speak to you folks, all you folks, first time here. Thanks so much, and energy from my side and energy from your side as well. I think it's all mutual. Thanks again. Appreciate that. Okie dokie. Cheers.
Cool.
Signing off.
Thank you so much. Stay safe. Take care. I'll see you guys in
Yeah.
the next session. Thank you.
Have a good weekend. Cheers. Bye, folks.